Hey everyone. In this video, we're going to take a look at some subsets of real numbers, specifically those that are rational and irrational. Okay, so first off, what is a set of numbers? Well, a set is a collection of objects, again in this case, numbers, and in a set we call those objects or numbers elements. Okay, elements of the set. Okay, looking more specifically, here's a subset of real numbers which are rational numbers, which are a set of numbers that can be written in the form a over b, where a and b are both integers. Pretty much what this is saying is, if it's a rational number, it can be written as a fraction, okay, with integers in both the numerator and denominator. Okay, we have a couple of examples of rational numbers down here, 1 and -1. Obviously, those are both rational numbers. 1 can be written as 1 over 1. And we could also write this one as -1 over 1. Both of those would be integers on the numerator and denominator. We also have 0.3 repeating. We know that can be written as 1/3. Okay, so it's a predictable repeating decimal. That is actually going to be a rational number. And we have 0.25, which we know is 1/4. Also can be written as a fraction with an integer in both the numerator and denominator. So that one is also going to be a rational number. Again, all rational numbers should be able to be written as a fraction. Okay, taking a look at some irrational numbers. That's a set of numbers that cannot be written as a quotient of two integers. Okay, for the most part, irrational numbers, the two popular ones are, we know pi is a famous irrational number, and also anything that you take the square root of that does not have a perfect square. Okay, so looking at a couple of examples, we have again pi, which we just mentioned. Sure, you can write pi over 1, but the problem is pi is not an integer. Okay, so this cannot be written as a fraction with an integer numerator and denominator, so pi is going to be irrational. Again, the square root of 10, the number 10 is not a perfect square. Okay, if you were to take the square root of 10 on a calculator, you would get a crazy decimal, and that would again be an irrational number. Same thing goes for the square root of 3. 3 is not a perfect square. Okay, perfect squares being like 4, 9, 16, 25. Those are perfect squares. Okay, 3, clearly not one of those numbers, so also going to be an irrational number. Okay, so here we look at some general operations that have rational and irrational numbers in them. Okay, in general, if you are adding two rational numbers together, you would get a rational answer. Okay, if you were multiplying two rational numbers together, you would get a rational answer. Okay, when you start mixing in the irrational ones, so for example, if we add a rational number and an irrational number together, you are going to get an irrational answer. And again, if you were to multiply a rational and an irrational number together, you would get an irrational answer. Okay, so let's take a quick look at a couple of real examples with these. Here we're stating whether each of these is going to be a rational or an irrational answer. Okay, so the first one, we have 3 square root of 30, which is really saying 3 times the square root of 30. Okay, the square root of 30 is not a perfect square, so we know that this one is going to be an irrational answer. Okay, based on the fact that we're multiplying a rational number 3 times an irrational number square root of 30. The next one, 10 over 4, we know can reduce to 5 over 2. Again, we have a fraction with a numerator and denominator. Both are integers, so this one is going to be a rational answer. Okay, next we have the square root of 12. We can reduce the square root of 12 to become 2 square root of 3, but even in that case, you still have that square root of 3, which is irrational. So 2 times the square root of 3, that's going to give you an irrational answer. Okay, again, based on the fact that the square root of 3 is irrational. The next one, -15 plus pi. This is a rational number plus an irrational number. So we know from the last slide that that is going to be an irrational answer. And 4.5 can be rewritten as 9 over 2. So that one is going to be rational because it can be written as a fraction. And 0.6 repeating, we know is 2/3. Again, a repeating decimal is going to give you a rational answer. Okay, it can be written as a fraction. All right, so there's some general info about rational and irrational numbers and those subsets of real numbers.